The question is, which one of the following assertions are correct? P. Adding 7 to each entry in a list adds 7 to the mean of the list. Q. Adding 7 to each entry in a list adds 7 to the standard deviation of the list. R. Doubling each entry in a list doubles the mean of the list. S. Doubling each entry in a list leaves the standard deviation unchanged. So, let's take a list L which has n elements x1, x2 till xn. So the mean E of x, expectation of x is basically mean, is equal to summation of all the elements x1 plus x2 plus till xn divided by n. So this is the mean of the list. The standard deviation denoted by sigma is equal to root of E of x squared minus E of x the whole squared. So this is the definition of mean and standard deviation. Now let's take the assertions P, Q, R, S. Finding mean is simpler than finding the standard deviation. So first let's take the assertions P and R and see if they are true. So adding 7 to each entry in a list adds 7 to the mean of the list. So initially the mean is x1 plus x2 plus x3 till xn divided by n. If you now add 7 to each of the elements, what you do is x1 plus 7 plus x2 plus 7 till xn plus 7. The mean will become, it's still n elements, so the mean will be divided by n. So this is initial mean x1 plus x2 plus x3, which is initial mean, let's call the initial mean m, plus 1, 2, 3, n times 7. So it will be 7n by n, which is equal to m plus 7. So we see that if we add 7 to each element in the list, 7 gets added to the mean of the list. So assertion P is right. Now let's see assertion R. Doubling each entry in a list doubles the mean of the list. So the entries in the list are x1, x2 till xn. So if we double each entry, it will become 2x1 plus 2x2 plus till 2xn by n. Now if we take 2 common outside, it will become 2 times x1 plus x2 summation till xn divided by n. So we see that this term is the original mean. So the answer, the mean is, the new mean is 2 times old mean. So assertion R is the right answer. So if you see the given options, options P and R both are true only in option C. Option A is P comma Q, P is true, Q you don't know if it's true. Option B Q comma R is true, Q you don't know if it's true. C, both options P and R we have proven to be true. So option D, R and S, R is true but S we haven't found out. But the point is, when in an exam you don't need to find the tougher part, the standard deviation, because you have proven that options P and R are directly true. So option C, P comma R is the right answer. So for assertions Q and S, when we need to find the standard deviation of the list, the easier way to do this is to take an example list. So let's take a list L 1, 2, 3. So the standard deviation of this list, as we saw, the definition of standard deviation is root of E of x squared minus E of x the whole squared. We will find this. So first x squared, we need a list. Here x is basically x1, x2, x3. So list, I will have a subscript x squared is 1, 2 squared 4, 9. So the standard deviation sigma is equal to root of E of x squared, which is basically the mean of this list. Mean of this list is 9 plus 4, 13 plus 1, 14. So 14 by 3. Root of 14 by 3 minus E of x the whole squared. So the mean of this is 3 plus 2, 5 plus 1, 6. 6 by 3 is 2. So 2 squared is 4. So this is sigma. Now take assertion Q, add 7 to the list, to each entry in the list. So now list becomes 8, 9, 10. List of x squared becomes 64, 81 and 100. So now sigma becomes root of, we need to find the mean of this list. So 100 plus 81, 181. 181 plus 64 is 5, 14, 245. So it's 245 by 3 minus the mean of this list, the whole squared. So the mean of this list is 10 plus 9, 19, 19 plus 8, 27. 27 by 3 is 9. So 9 squared, which is 81. We see that there is no correlation between this sigma and this sigma because the L of x squared increases exponentially. So basically, if you add 7 to each entry in the list, it does not add 7 to the standard deviation. It increases exponentially. So assertion Q is not right. Similarly, if you double each entry in the list, we see that instead of 1, 2, 3, it will become 2, 4, 6. L of x squared will also increase exponentially, which means the standard deviation will definitely change. Therefore, assertion S is also not right. So option C, P, R is the right answer.